Hello, sixth grade. These are summary notes for 4.2, the distributive property. If you are writing something down and I'm going too fast, remember you can pause it, but anything I write down, please make sure you write down in your notes. So the distributive property, we started by making it visual. So in the diagram below, a large rectangle has been made from two smaller rectangles. Use the distributive property to write two different expressions that can be used to calculate the area. So first, let's review. Area, remember, is length times width. Okay? And you've actually used the distributive property when you learn to multiply numbers. So in other words, in fourth grade, you don't have to write this part. In fourth grade, when you had maybe 35 times 8, okay, you broke this up into 8 and 30 and 5. And then you said 8 times 30, 8 times 3 is 24, add a 0. 8 times 5 is 40. And then you added them together because you wanted this whole area, and you got 280. That was using the distributive property. Hang on, we're going to continue with the visual, because when you get into algebra, there's another way of using this visual that you learned in fourth grade. So once again, we're dealing with a large rectangle. So I'm going to put this in red for you. You don't have to, but here's what I mean by the large rectangle, what I just made in red. Okay, so a large rectangle is made from two smaller rectangles. Rectangle 1 here and rectangle 2. Okay, we're going to use two different expressions to show how we can get the area of that red rectangle. Now, my length of my side here is A. That could be any number. This little piece is B, and this piece is C. I know I'm using letters instead of numbers, but that means it can represent any number. So, the first thing on the visual, here is the area of rectangle 1. Okay, so if I found the area of rectangle 1, I would be doing A times B, just like I did here, 8 times 30. Okay, then another way of showing that I'm not using an X in there to multiply because I have letters. So another symbol for multiplication is when you have a number or a letter attached to a parentheses with something in there. So that means multiplication. Okay, so I have A times B. Okay, then I'm going to find the area of rectangle 2, which is this lighter rectangle. Okay, well, my length is A, as you can see, and my width is C. So I have A times C. So if I want them all together, I'm going to say I multiplied A times B, and I'm adding it to A times C, just like here. Okay, I multiplied here, I got 240. I multiplied this piece, and I got 40. And then when I add them together, I get the whole rectangle. Okay, so that is expression number 1 right here. Okay, I'm multiplying A times B, and I'm multiplying A times C. The other way of writing it, okay, so the other expression is, again, length times width. Well, if my length is A, there it is. My width could also be these two letters combined, added together. I'm combining them. So I would say B plus C. So here we go, B plus C. So my length is A. Here's my length. And my width, okay, is B plus C. Length times width. Okay, so my other expression is A times the quantity of B plus C. So expression number 1, expression number 2. Okay, so by definition, the wordiness now comes in. The distributive property is multiplying the sum of two or more addends by a number that will give the same result as multiplying each addend individually by the number and then adding the products together. All right, so now let's put some numbers and things together with this. Turn to the next page. So in the diagram below, once again, a large rectangle has been made by two smaller rectangles using the distributive property. Write two different expressions that can be used to calculate the area of the large rectangle. So here now we have numbers. Okay, so again, my first thing is I'm writing, then I'm multiplying and finding the area of section 1. So I would say I'm doing 7 times 5. Now in this case, if you want to put an X and say I'm doing 7 times 5, that's fine, because now I have numbers instead of letters. Then remember, I'm adding the product of section 2, which would be 7 times 12. Okay, and again, if you want to write it with the same format as the other one, it would have been 7 times 5 plus 7 times 12. I don't want to be writing in 10. Let me switch back to my pencil. Now, that was number 1. Okay, the second one would be to say again, my length is 7, and my width of my large rectangle would be 5 plus 12. 5 plus 12. Okay, here I did them, the rectangles individually and added them together. Here I added this and multiplied by my length. Now let's look at this. It's just the same thing turned around. Okay, what side do both of these share? They share this side. Just like here they shared this. Let me get my red. Both rectangles shared this side. Here they share this side. So if I want to find my rectangle number 1, I would be doing 4 times 2. Okay, or I can even switch around and say I'm doing 2 times 4. Let's say I'm doing 2 times 4. And let's use this method. Then here, I'm going to do 8 times 4. So I'm adding 8 times 4. Okay, again, many different ways to write it, but the idea is, hey, this is my common number. I have this rectangle, and then I have rectangle 2. Now, my other way of doing this, okay, well, I have 4, okay, and then this side is the side I'm adding up. So I'm multiplying that by 2 plus 8. Or again, I could say 2 plus 8 times 4. Doesn't have to be in the other order. So again, how does this help us? Find the product of 15 times 34 by using the distributive property. Justify the solution by using areas of rectangles. So this is exactly, let's say it's a rectangle, and maybe I have a rectangle that is 15. And I'm breaking this up. I want here and say this is 30 and this is 4. So I can say 15 times 30 plus 15 times 4. 15 times 30 is going to be 450. 15 times 4 is going to be 60. So that's, I can do those in my head instead of trying to do this long multiplication, and then now add 45. Okay, so write again, 450 plus 60, okay, is going to give me 510. So that's how I can use the distributive property to break down this number and to help me out. Okay, let's look at the next situation. The dimensions of the rectangle are whole numbers. Find the area of the rectangle composed of the 2 smaller rectangles, then find the dimensions of all 3 rectangles. Well, they're given the area, so the total area of everything, okay, would just be to add 21 plus 28. Okay, and that would be 49. Okay, however, if I want the dimensions, okay, I have 21 and 28. So here's where we circle back to our common factors. And I need to think of a common factor between 21 and 28. Because remember, they share a common side. Right? These are your common sides. So what is that? They share that common side. Well, a common factor can be any one of 21 and 28. In this case, is going to be 7. So 7 times what gives me 21? That length has to be 3. 7 times what gives me 28? Okay, that length has to be 4. Okay, so now here's where I can check my work here. Okay, remember, I could also say that length, 7 plus 3 times 4, okay, becomes 7 times 7, which is 49. So again, that all kind of circles around with each other. So these were the summary notes for 4.2.